BIM is, from the real estate perspective, the perfect foundation for a building twin. We made BIM mandatory for all new constructions that may come. But not only that, we try to leverage the digital twin and the BIM data throughout the operational phase of the buildings as well. And for those who are familiar with the real estate domain, they know that is quite a challenge that we face here, and all of us face currently. But all that led us to where we are today in the collaboration with DI now.
I'm Greg Arnott, and joining us on today's episode is Thomas Reinmann, Innovation Technology and Sustainability Expert at Siemens Real Estate, and Derek England, NX Product Manager at Siemens Digital Industry Software. Before we begin, let's meet our guests. Thomas, would you like to go first? Please tell our listeners a bit about yourself and what happens at Siemens Real Estate.
Sure, Greg. A lot of people don't know is that Siemens Real Estate is one of the world's leading corporate real estate managements. We care for all owned and rented spaces that houses Siemens, no matter if it's an office or a factory, a whole campus, or even now a city district like we plan it in and realize it in Berlin, Siemensstadt Square. But what differs us from all the other in-house corporate real estate management is that we are not a simple cost center. So we have our own profit and loss responsibility.
And can you explain what that entails exactly?
What does that mean is that we need to care for ourselves. So we need to refinance our spendings. We need to pre-finance the spendings on facilities for the business. And we need to contribute to the overall performance of Siemens. But not only that, we are constantly competing with the market. But being also part of a world-leading tech company like Siemens, being part of Team Siemens, digitalization and innovation is part of our DNA. So, I mean, we have everything on hand the others need. We have everything in our portfolio. So we constantly try to drive new topics, be ahead of real estate trends, try new things, being customer zero, doing things differently and dig into processes and so on. And we try to create together.
And how do you feel that sets Siemens Real Estate apart, especially in regards to building information modeling, or BIM?
Siemens' motto is to combine the real and the digital world. And with the burning topic of industrial metaverse ahead of us and everywhere around, we think that BIM is, from the real estate perspective, the perfect foundation for a building twin. Yeah? And by saying that, we made BIM mandatory for all new constructions that may come. But not only that, we try to leverage the digital twin and the BIM data throughout the operational phase of the buildings as well. And for those who are familiar with the real estate domain, they know that is quite a challenge that we face here, and all of us face currently. But all that led us to where we are today in the collaboration with DI now.
Thanks so much, Thomas. And can you also explain a bit about how Siemens Real Estate utilizes digital twin technology?
Let me start with a digital twin example. Nanjing was a lighthouse project for Siemens back in the days. It was planned and simulated completely digital. We combined factory data, shop floor data, performance data, and even building data to create a complete digital twin of the building. And that gave it the name of a digital native factory. And it won even a Werner von Siemens award back in 2022. But for those who worked at the project, they could definitely relate to the analogy of the duck. So we were on the surface, everything seems to be calm, but underneath the water, we were constantly paddling to move the project forward and to meet deadlines. So while Nanjing was a great success overall, we have been pretty clear that these processes were not scalable back then. And now with the globalizations, dozens of projects need to be planned simultaneously. So we need to get easier and more integrated processes. So that is when Derek and I started to collaborate, and our goal was to significantly improve these processes and the collaboration and integration of BIM and shop floor data.
Derek, you've also told me about your recent collaboration with Thomas to improve the process of integrating the BIM model with the shop floor layout. Can you please now introduce yourself and give us a bit of an explainer on the way Siemens Digital Industry Software supports Siemens Real Estate and its customers?
Thanks for hosting, Greg. It's great to be with you. As the NX product manager for AEC and BIM, it's my responsibility to support our NX customers in this space and ensure that NX is the best design tool for this industry. So I'm passionate about working with our customers and understanding where we can improve design and collaboration processes. So about a year ago, Thomas reached out to Siemens Digital Industries in order to establish a connection between BIM files and shop floor planning to create a digital twin. This immediately piqued my interest, and I was eager to engage with Siemens Real Estate, and I'm excited to be with you today and sharing the best practices that we developed together.
Well, that's very exciting stuff. Thomas, Derek, let's dig in and hear about what the two of you have been up to. Thomas, can you give us an overview of the BIM and shop floor design and collaboration workflow?
Although the BIM and the mechanical CAD world are integrated together for design reviews, these two worlds have their own independent design processes and tools and so on. So SRE owns the BIM data due to digital operations, like I said. So we keep the data up to date with the help of our external facility managers. And the shop floor equipment and shop floor planning is owned by the engineers. So therefore, architects do not reposition shop floor equipment, and the engineers do not reposition walls or columns and so on. So the BIM data needs to be continually refreshed and up to date and perform the frequent design reviews and alignments and so on. So once the BIM data is imported into NX, equipment gets positioned relative to walls and columns. For example, a building of production layout may include more than 500 equipments. We have their soldering lines, we have manual assembly stations, robotic assemblies, and so on. And we do all that to validate the layout and design fully digitally in 3D for the first time.
And have you run into any challenges when connecting these two worlds?
When there is a change needed, for example, on the architectural side, so the architect may shift the wall, then the model needs to be handed over again. The engineer needs to review the changes, needs to be aware of the changes, need to adapt the shop floor layout accordingly. And then the updated shop floor design again needs to be transferred to the architectural side. And the new requirements on infrastructure, for example, need to be adapted. Yeah. So architects typically use for working with the BIM files, Naviswork or Revit, for example. So the data needs to be imported into that tools. So we get the shop floor in an IFC format, in the open IFC format. We import that data as a single component into Revit. And then with the NX data on hand in Revit, we try to resolve maybe issues or collisions between a shop floor equipment and a column, for example. Ideally, these design reviews take place weekly or even daily if feasible. So a vision would be that there is a constant reflection of the shop floor in the BIM world, and vice versa. There is a constant reflection up to date in the NX world. That would be my wish. But speaking of the past, for Nanjing, for example, these reviews have taken place regularly, but the effort was quite high. So we needed to first export the BIM data into IFC, imported that data again in NX. Then we needed to optimize the model, reduce the details, and so on. So every review and every milestone was a brand new study by its own, let's say that way. So we needed a definitely more efficient way of importing data into NX.
Thank you, Thomas, for that overview of the design collaboration workflow. Thomas, Derek, I'm wondering, can you tell us some of the hurdles you've experienced with the design process? And how do you ensure that the proper requirements are being validated?
This type of early design analysis is difficult because both worlds are not connected. So they are kind of disconnected. Some years ago, the design and planning was even done only in 2D, for example. Tools vary, file formats are not compatible with each other. And then you have the architect and the engineer maybe having different understanding by talking about the same thing. So you need several iterations to narrow down then to a common conclusion. And even by trying this, there might be an issue or a clash that's undiscovered. And then at the end, only a workaround can solve it. So it was pretty clear to us there must be a better way of doing this. So at the very early beginning of a project, everything starts with a demand clarification. So the shop floor engineers provide an early understanding of what they need. So for example, floor size or manufacturing floor size, ceiling heights or HVAC demands. These requirements get documented and clarified. And with this early demand, we create a rough first BIM model of the building. And this BIM model at this very early stage with walls, columns, and first ceiling heights and so on gets handed over to the engineers, shop floor engineers. And they can immediately start at this early stage already to place objects on the shop floor, to reserve spaces and clearance zones and so on. And these early placements can only be rough blocks that does not need necessarily to be the final shop floor equipment. And with this rough shop floor planning played back to the architect again, the shop floor and the building can be adapted to the demands again. And so with each iteration, you add more and more details on each side and get a better understanding for the demands. And so the models evolve from time to time.
Yeah, this is a workflow that Thomas described is similar to what I've seen other customers do. Lots of times, like they'll do a 2D shop floor like layout, and that's really useful, right? For early conceptual designs, it enables you to quickly kind of reposition things and do, evaluate different layout configurations in 2D. But as the design, progresses, right, we need to also evolve the level of detail, right? So one of the drivers to move to 3D layout was the ability to detect, height issues, right? So sometimes we would find that equipment would interfere with beams or HVAC equipment, and these wouldn't be discovered until very late, and resulting in last minute changes and costly delays. So The way I've seen it typically is like once the shop floor layout is proposed, the architect will begin designing the facilities and the engineers will begin positioning their equipment in context of this building. And each domain, architects as well as engineers, develop their designs independently from each other using their preferred tools and processes over time. So when BIM is done, and the machine layout is done in their own tools. And so for companies like Siemens Real Estate, they must develop processes to enable the BIM and the mechanical CAD worlds to kind of work together to create a complete digital twin. So during the design process, regular design reviews ensure building components such as walls and columns and beams don't interfere or are too close to shop floor equipment. This BIM data is really a lot different than mechanical CAD tools, right? BIM CAD definitely has a structure in the form of relationships, but all that data is contained in a single part file, while mechanical CAD uses assemblies and components to create structure.
Have you found one to be more beneficial than the other?
Each kind of has their own benefits. For example, with assemblies, you have the ability to have multiple designers to collaborate simultaneously during product design. because there's these differences in the way we structure BIM and mechanical CAD architecture, it was a little bit of a challenge. How do we bring these two worlds together? When you import BIM data into NX, what's the best mechanism and method to import this data into mechanical CAD? BIM data import was one of the first topics that Siemens Real Estate and Siemens Digital Industry worked on together. Most of the AC CAD tools, like Revit and Allplan and BricsCAD, MicroStation, Tekla, etc., they collaborate using IFC kind of as their preferred neutral file format for exchange. And when importing AEC CAD or BIM CAD into NX, you have lots of different options, right? One option is to try to preserve the BIM structure as assembly structure, right? Or you can flatten the BIM structure into a single NX component, or you can import the BIM data as a precise boundary representation or lightweight facet data. And so I couldn't make those decisions like what's best for Siemens Real Estate. So this is really where I really needed to work closely with Thomas and his team to understand more about their workflow and their requirements.
Well, I'm sure that close collaboration has been indispensable. Thomas, tell me, what are some of the challenges you faced integrating the BIM and shop floor data?
I see mainly three challenges here. So first of all, the data format. The interoperability is really challenging because BIM CAD and mechanical CAD data formats are so different. Speaking of IFC, all BIM CAD data is essentially stored in a single part file, like Derek said. NX, on the other hand, uses components and assemblies. And BIM CAD workflows highly rely on BIM attributes for collaboration. So there was the need to preserve these attributes within NX. Then the second challenge I would call is positioning. So BIM CAD workflows rely on everyone designing around the same project coordinate system and base point. This project coordinate system is essential when aggregating data from multiple CAD systems together. And the third challenge is the complexity, for sure. Then because we learned that NX translator options are set to generate the best quality data, but these best quality options did not provide the best output for what we need for BIM and shop floor collaboration. Trying to replicate the BIM structure within NX using assemblies added, for example, a lot of unnecessary complexity. And translating BIM CAD in NX assemblies with precise BREP data resulted in very long translation times and very large data sets. And we also needed to consider what BIM data is relevant for shop floor layouting, because, for example, details of a door or a window are completely unnecessary or not adding any value to the shop floor planning team.
Derek, are these challenges that Thomas has talked about similar to what you've seen in other industries?
Collaboration between automotive and aerospace OEMs and their suppliers is so different than the way architects and general contractors and subcontractors and owner-operators collaborate. When a project begins, the general contractor hires multiple subcontractors to design various design elements within a building. For example, like steel structures or piping, electrical, plumbing, HVAC, fire safety systems, etc. So the general contractor initially provides each subcontractor with an initial design, their design context, and each discipline is designed independently. So each subcontractor has the flexibility to use their preferred design tool for their portion of the design. And this initial design context becomes out of date really quickly. And so each designer is essentially working within their own data silo. When the general contractor wants to review the entire design, right, the data from each subcontractor is then aggregated into another software to find interferences and clashes. And this software is really good at finding physical clashes and documenting interferences, but many requirements must be manually checked and validated.
Okay, and would you mind walking us through that process?
The general contractor prepares a document for each subcontractor notifying of their changes that are required, and then each subcontractor goes off and makes these changes again in isolation. So the second design review can prove to be even more difficult than the first design review, because now you have to understand what's changed from the first review, the first revision to the second revision, right? And so how can you tell what's changed? You can compare like body IDs and things like that. But, did that body move, or was it, enlarged? It's easy to detect what's new or what's been deleted, but it's really difficult to see how things have changed. And so you spend a lot of time analyzing what's changed. And without history or traceability, it's really difficult to track these changes. Typically, the majority of time is spent just analyzing these revision changes. And so this process of validating and aggregating design is time consuming, it's error prone, and because the effort to aggregate and validate the data is so time consuming, it's difficult to kind of plan for and make design changes, like big design changes, because then they have to understand how will these impact all the different disciplines, right? And it's difficult to make sure that these changes get propagated to all the disciplines properly, and that we can appropriately understand the impact of this change. Lots of times, these late changes, will result on-site issues and cause delays and additional costs.
That's really interesting. Have you found that Siemens digital industry software tools are supporting SRE's workflow? And can you identify some of the challenges that you and Thomas have faced?
When we translate data, if you look at the settings that we used, we want to get the highest quality, highest fidelity data possible, right? And that's the out-of-the-box settings. But what we found was when we use this best quality IFC translation options, it could take hours to complete. And it would create thousands of NX parts and gigabytes of data, right? And then managing all these parts is challenging. And then, if the engineers are managing this data like in a tool like Teamcenter, then you have to import all this data in there. And it just was a lot of overhead to do that. Also, with the shop floors was surprised that things like items like doors or columns that were essentially all identical, when we import them through IFC, they were surprised to find that they were not instances, right? In CAD, mechanical CAD, you would see that as an assembly instance. And so you just have one object that's represented in multiple places. But when we came through IFC, each one was a unique one. And so that surprised them too. And but that's one of the challenges of going through a neutral file format like with IFC. So one of the ways that we kind of explained why that was challenging is, for instance, if you had a column going up like kind of a pitched roof, for example, that column is identical, right, in the kind of the profile of it, but the height could be different. Or if you're getting a column from the same kind of part family, it sees it as kind of the same component in their authoring tool, but in NX, it's a different shape or a different height. And so in NX, it can't be an identical instance, right? Because it's different in shape. And so while in the authoring system, it seems like it's the same, in mechanical CAD, it's not, it's different. And so because we can't detect that, sometimes there are identical instances that are represented as unique assembly instances, and that surprised them, right? So there was some learning that happened as we translated this data.
So it seems apparent that translating and organizing BIM data for the shop floor has been challenging. Thomas, you mentioned earlier the importance of positioning when aggregating the data. What are the hurdles involved with positioning in these workflows?
So in the architectural domain, we usually define a common base point at the very beginning of each project. So due to its complexity, each domain, for example, structural design, electrical design, mechanical, plumbing, and so on, has its own model. And there is a specialist for each domain and a special tool creating that layer and 3D planning. So our data environment needs to combine all these models to one holistic building model at the end. And this only works because of the same base point every layer is aligned to.
And what about the technical issues discovered when positioning data?
It's difficult to kind of design the shop floor and the building in isolation and then try to coordinate and position them relative to each other later, right? And so what we found best was to, provide the shop floor an early project point that we can design around, right? And that made it very easy to aggregate the data later and pull it all together. We found early on some discrepancies when importing and exporting data, like via IFC, using the default reference point options, like for Revit, for example. and the positioning of the data seemed inconsistent. This is when we discovered that in the importance of utilizing a defined reference point when we were exporting data from Revit to IFC. The default option was to use, for example, the internal origin as a reference point. But when importing IFC into NX was using the absolute zero option, right? So the BIM CAD tools need to support lots of different types of base points and coordinate systems. So we simply needed to make sure that the translators were using, a common data point. We just found recently that, where's the best point to use? For example, like there's a site coordinate point and there's a project coordinate point, which one works best for the design. And so those kind of decisions need to be made by, the architects and the engineers. And it doesn't matter which one you use. You just want to use the one that's most convenient. And so just need to go through that process of deciding which one is best. And NX and these other tools support that.
Okay, Derek, before we wrap up this podcast, I'm wondering if you can summarize the lessons you've learned collaborating with SRE.
We did discover that there's very little value kind of replicating the entire BIM structure as an NX assembly. It really made it really complex to import this data into Teamcenter, and it really wasn't a lot of value. For early collaboration workflow, the shop floor can use, a single NX part file where all the BIM objects are represented using lightweight facets. All those attributes that are associated with those objects are preserved and can be viewed in NX and in the architectural CAD tools. We also found that we didn't really need the, precise boundary representation wasn't required. Using lightweight facets created much smaller data sets. The translation times were faster. And it was, those lightweight facets were plenty sufficient for positioning shop floor equipment. All the global unique identification attributes are preserved. We saw examples where translating an IFC file could take hours to process, right? We saw one example where an IFC translation took over 4 hours to complete and created 3+ gigabytes of data. But you doing that same IFC file, using the lightweight options and creating a flattened structure took less than 10 minutes. And the overall file size was just 200 megabytes. And so that was, that's a significant difference and much easier to manage, a single 2 megabyte part file versus managing hundreds or thousands of individual parts with, that are 3 gigabytes or more of data. I think finally, positioning, right? Making sure that we coordinate and that multiple contractors, using multiple BIM CAD tools. And it's really important that we have a common coordinate system that we're all referencing when we're exchanging data. Trying to align things after the fact was really difficult and really not efficient. So as long as everyone's designing around the same coordinate system, it worked out great.
That definitely makes sense. I'm curious, Thomas, where would you like to see advancements in your collaboration processes in the future?
If I could wish for, I'd love to interconnect both worlds. So having a permanent synced reflection of each other's domain model in the respective tool. No manual effort anymore, no repetitive importing, no updating of manual updating models or conversations needed. So as soon as there is a change, for example, on the building side, the engineer gets an implication that there is a change and options how to adapt to these changes fully automatically, fully digitally. That would be my wish. For digital process addressing issues and communicating requests, on